Chapter 3, Quantitative Demand Analysis. The learning objectives for Chapter 3 are elasticities. What are they? They measure the relationship between two variables, specifically on a percentage basis. We'll find out the characteristics such as elasticity, whether it's elastic, inelastic, or unitary elastic. Then we'll look at own price elasticity, which relates the price of a good, call it X, with the price of that same good of X. And that's why it's called own price. It's the effect of the price of your product on the quantity that you will sell. Next, we'll look at cross-price elasticity, which compares one good, say X, to another good, say Y, and see if there's a relationship, whether it's a substitute or a complementary product. Fourth, we'll look at income elasticity, which shows the impact of income on the amount purchased. Some items you'll find are normal goods, which means that as your income goes up, you buy more. Some items are inferior goods, which means as your income goes up, you actually buy less. Fifth, we'll look at other elasticities that relate to other factors, such as advertising, or in different forms, such as linear versus nonlinear expressions. And finally, we'll look at how can we estimate demand functions when we don't have the luxury of a nice mathematical function. So that's what we're going to cover, all types of things related to quantitative demand analysis. Why is elasticity important? Well, it's important because it measures the responsiveness of one variable based on changes in another variable. And specifically, we're looking at percent changes. And we'll find different applications of this along the way, but the general term of elasticity has multiple purposes, so we'll look at it at an overall level first. Why do I care? Why do I care about elasticities? Well, some examples are, well, if I raise prices, will I lose customers or make more profit? So this is obviously important, and that's called own price elasticity. The next example is, if my competitors raises prices, will my sales go up or down? That example is cross price elasticity. Next is, if the economy is in a growth phase and incomes rise generally, will my product sales go up or down? And that's called income elasticity. So the calculation for all of them in a kind of a generalized term is as follows. The elasticity of two variables, such as G and S, are mathematically expressed as elasticity of G based on S equals the percent change in G given a percent change in S. And the functional relationship and how we will use to solve these elasticity problems is dg ds times S divided by G. Uh-oh, is that calculus again? dg ds? The answer is yes, but you've mastered calculus, right? Well, at least the first derivative. And again, that's all we're going to need here in this course for calculus is the first derivative. So you're okay. Hopefully you still remember it from the last chapter. So interpreting elasticity is also quite important. We go through the trouble of computing elasticity, and we then look at the sign. So first, if it's positive, that means the relationship is a positive relationship. And if one goes up, the other one goes up as well. So if prices go up and quantity goes up, that's a positive relationship. If it's negative relationship, if one goes up, the other one falls. So that's all there is to it as far as the sign is concerned. Positive, like a positive correlation, one goes up, the other goes up. Negative, just like negative correlation, one goes up, the other goes down. All right. Next is the absolute value of the actual measure of elasticity is also important. If the absolute value is greater than 1, then it's highly responsive. If it's less than 1, then it's slightly responsive. Again, these are absolute values, right? So that's ways we will be able to use the elasticity and make some generalized comments before we go into actual numbers. We just look at the sign or the magnitude and get some feeling for the responsiveness of that particular measure.